Here I am again discussing another interesting paper. So it is an interesting paper because it asks a really interesting question, which is, are growth options priced correctly in equity markets? And the answer is no, not even close. And they get these alphas that are annualized are between 10 and 17%. And so when I first started reading this paper, I thought, oh, I know how to compute investment models. I can trade on this. And then I decided, no, I should write the discussion. But the first thing that comes to mind when you see numbers like that and you think, boy, where did that come from? Those are very, very low. That's big money. And that's what most of my discussion is going to be about. And the first part is just about the mechanics. So I'm just going to summarize what these folks did to get what they got. So they estimate the parameters of a very standard investment model on an industry month basis. So that's a lot of estimations. They do that in three parts. They estimate a bunch of parameters very sensibly, no problem there, outside of the model. And then they take all these parameters, plug them into the model, get a model implied valuation, compare that to the real actual value, and then pick two extra parameters to get those residuals as small as possible. And that's just a really simple, nonlinear least absolute deviations estimation. It's not, that part's not that high tech at all. And that seems like a sensible thing to do. I have no problem with that. You'd think I'd get all picky about that, but no. But the measure of misvaluation then is this residual from that last estimation, and it's for each firm in an industry, and then each of those estimations is done per industry per month. So there's a lot of stuff going on here. Then they use this measure in standard reduced form asset pricing tests. That's it. I'm not going to talk about the asset pricing tests. I'm going to talk about the investment. And then there's one interesting twist. This is the part of the paper that I found the most convincing. They take the model and they use it to measure growth options versus assets in place, and they find that most of the alpha comes from the high growth option firms. I thought that was interesting. It made me think, maybe there really is something here and that it's interesting. So I think this is a paper with some big pluses and some fixable minuses. I really like the idea of taking an asset pricing model seriously, applying it empirically, and trying to quantify mispricing. That's awesome. I think that's a great approach. And as I said before, that growth options result makes me think there probably really is something here. And the rest of my discussion is going to be about what I think could be fixed. And I'm going to do this in two parts. I want to sketch the model, and then I'm just going to provide a to-do list. So this is a really, really simple model. It starts with a demand productivity shock that follows a geometric Brownian motion. Up there, line 1. Capital is the only factor of production, and capital produces output. That first term is after tax. Then there's that little demand shock, capital raised to the theta. Theta is less than 1. Pretty straightforward. Capital depreciates at a constant rate. There's a proportional cost of investment. There's a constant discount rate R, and the firm maximizes its expected present value under the risk-neutral measure. If that were the whole model, and it's not, because he left out one important part, if that were the whole model, the solution would be textbook. And in fact, the model would just collapse to a static model in which the firm equated the marginal product of capital with the user cost all the time. In this simpler model, you could calculate growth options and assets in place and their relative values, but it would be meaningless because it's a stationary model where this period is like that period, it's like the period before, it's all the same. So it's not really a meaningful decomposition. But there's one friction in the model which makes this decomposition meaningful, and that is they put irreversibility in there. As is standard in an irreversible investment model, you don't invest for a while until that marginal product gets high enough. And then you take the plunge and invest. So there's an inaction region. They very nicely get a closed form solution for the value of growth opportunities versus the value of assets in place. And the distinction is meaningful because of this optionality of waiting to invest. right? So that's where this idea of growth options having some sort of differentness comes from. It's from the irreversibility in the model. So that's a really simple model. As you know, I'm not an asset pricer at all whatsoever, but I know a little bit about asset pricing models, and this is a super simple one. And I think of simple models as really useful for insights. My attempts at fitting really simple models to data have usually ended up in disaster, and so I think of more complicated models as being those that are more useful for quantitative exercises, and this is a quantitative exercise, and this simple model is already very well understood. It's actually a special case of one of the old Abel and Eberle papers. So I want to answer this simplicity question in two ways. Can you make the current model better? And might you do something else? And first, maybe the simplest model's fine. Maybe they can just tweak it a little bit. The first thing that struck me is that their estimates of the curvature of the production function are crazy low. They're just crazy low. So they get about 0.32. If you go to structural corporate finance and kind of average everything that everybody's done, it's about 0.75. If you go to the macro guys, it's 0.9. 0.32 is a bad number for two reasons. It basically implies that Tobin's Q is way over 10. It also implies that demand is about as downward sloping as a double black diamond. So you wonder if that might be driving some of the results, because we know that that parameter within this the context of this model makes no sense. I'll come back to that. The other thing that the authors do is they throw out all of their negative operating income firms. Why do they do that? Because in the model there is no negative operating income, but that's problematic because 25% of firms have negative operating income, and almost all of those are firms that probably have high growth options. I will come back later to a way to fix that. The other thing I thought was utterly missing from the paper is, does this simple model do a good job with investment? It's an investment model, right? And so you'd be interested to see if it does a good job with investment. Sadly, I'm kind of pessimistic. I have this paper that says that this class of models does not so well on firm level data. There's not too much inaction in firm level data. There's this old paper by Bertola and Caballero that says that these irreversibility models work not so well in aggregated data. Nonetheless, I'd still be interested to see two things: how well the model works to help us understand investment, but also I'd like to see the authors use some investment data to help discipline the model. And I think that then the 3.2 would go away, the 0.32. Okay, that's it with the now. What about that 17% alpha? The first statement's pretty obvious, but I'm going to say it anyway, and then I'm going to add a lot of detail, and then it'll be less obvious. But if you want to do an exercise like this, if it's going to be convincing, the model has to be pretty convincing. And these results could be spurious if the model's wrong, but that's not everything. The model has to be wrong, and anything that's omitted from the model has to be correlated with known risk factor, with some, not even known, but just some risk factor. And those reduced form regressions can't be picking those risk factors up. So if that's the case, who knows what's going on? The list of possibilities is endless. What I would like to do is focus on 4 that I think would let the authors get a better sense of the economics behind their results. So here we go. The 1 year Jonathan isn't here. So this was my first I can't believe this paper is almost 20 years old. This was my first introduction to modern asset pricing when I switched from economics. And there are many lessons in Berk, Green, and Naik, but one of the lessons is that the risk you have from optionality is not just from the growth options. It depends on whether the options that disappear from the assets in place that disappear from the face of the earth have the same or different risk from the growth options. That's utterly missing from the author's model because they just have this constant appreciation rate. That would also be easy to fix. You just put a fixed cost of adjustment in there. You have optionality on the upside, optionality on the downside. They have different risks. that would work. Why might that be why might that be causing problems? That might be causing problems because remember, what's a misvalued firm? It's a firm that has a high residual in a regression. So if the Berk, Green, and Naik model is the real model, then those high residual firms might have a lot of risk. That's the problem. Here's another lesson from the Berk, Green, and Naik model. Why do the risks of assets in place and growth opportunities differ? They differ because their cash flows covary differently with the pricing kernel. There's no pricing kernel in this model. It's under the risk neutral measure. The authors are careful to do a quick fix to go back and forth between the P measure and the Q measure when they measure growth rates, but that won't get at the correlations. That's got to mess up the calculation of growth opportunities and assets in place because you're getting the discounting wrong if you've got those correlations wrong. So that's something I worry. That's something I worry about. And then there's Carlson, Fisher, Giammarino. This is a fun paper. It's a little bit of a simpler model, but they make more points because it is a simpler model. And one of the points they make is that operating leverage matters. So if in the real world there is operating leverage, and we think there is, and there's no operating leverage in the model, then all those mispriced firms, all those residual firms might just have operating leverage. It might just all be operating leverage. One thing that's neat is that it would be easy to put operating leverage in the model, and then you wouldn't have to delete 75% of the biotech firms, and I think that would be interesting. And then one last lesson. We'll fast forward 10 years. Leonid and co-authors Dimitris have made the point that if you have a model that has shocks not only to assets in place, but to growth opportunities, then the returns of these high growth opportunity stocks covary, and that covariance creates a risk factor, which is kind of a neat result. So what if the world is a disembodied technological shock world, and they're estimating the wrong model? Those residuals are going to be risky, and then they would show up in those asset pricing tests. I could go on and on and on, because there are lots of models out there, and they all have all sorts of different features. And maybe the reduced form regressions do control for all of that risk, but it would be nice to know. We don't know, we can just speculate. One problem is the model would lose its closed form solution, right? And I'm sure they're thinking, no way, I am not. So by my reckoning, I counted all the industries in the appendix and counted all the months in the data. They're estimating 1,925 doing structural estimations. That ain't nothing. So yeah, so that ain't nothing. In modern computing, if you just used a cluster, that might take a couple days. It wouldn't be hard. 5 years ago, impossible. Now, piece of cake. So I think this is a paper with a lot of upside potential. It's a super interesting question. It's also an interesting way to answer the question. I just have a hard time thinking that it's mispricing if they've got a model that's just way, way, way too simple. But I think that's really fixable. And if they fixed it, I think the more important thing is optionality is not just irreversibility. There's all sorts of aspects of optionality that matter for asset pricing, and we could learn empirically which of those matters. And now I need to end with a disclaimer. Igor over there was my PhD student several years ago, and I have just done what any good advisor would do and give him a lot of work.